There is something wrong with the night sky. Every point of light you have ever stared at is moving away from you. Not slowly, not gently. The entire universe is stretching apart like dough rising in an oven, and every galaxy you can see is riding that expansion away from you right now. You cannot feel it. You cannot see it. But it is happening in every direction at every moment, and it has been happening since before your species existed. So how do scientists know this? How do you prove that everything is flying apart when you are stuck on a tiny rock looking up? The answer starts with a sound you have never heard coming from a train you have never seen. Imagine you are standing on a train platform. A train rushes past you with its horn blaring. As it approaches, the sound waves compress and the pitch rises. As it races away, the waves stretch and the pitch drops lower. This is called the Doppler effect, and it works on every kind of wave in the universe, including light. When something moves toward you, its light waves compress and shift toward blue. When it moves away, the waves stretch and shift toward red. Scientists call this redshift. And in 1912, an American astronomer named Vesto Slipher at the Lowell Observatory in Arizona pointed his spectrograph at distant spiral nebulae and discovered something nobody expected. Almost all of them were redshifted. They were moving away from Earth. At the time, nobody knew what a galaxy was. These fuzzy patches of light were still called nebulae, cloud-like smudges inside our own Milky Way. But Slipher had just found the first clue that something enormous was happening in the universe, a clue that almost nobody understood yet. Then came a man who changed everything. In 1924, an astronomer named Edwin Hubble used the 100-inch Hooker telescope at Mount Wilson Observatory in California to do something no one had done before. He measured the distance to the Andromeda Nebula using a special kind of star called a Cepheid variable. These are stars that pulse like a heartbeat, brightening and dimming on a regular cycle. A woman named Henrietta Leavitt had discovered in 1912 that the longer the pulse, the brighter the star. That meant you could measure how fast a Cepheid was pulsing, figure out how bright it truly was, compare that to how bright it looked from Earth, and calculate the distance. Hubble did this for Andromeda and proved it was far outside the Milky Way. It was not a cloud inside our galaxy. It was an entire galaxy of its own, millions of light years away. The universe had just gotten unimaginably larger. But Hubble did not stop there. He combined Slipher's redshift data with his own distance measurements and found a pattern so clean it shook the foundations of physics. The farther away a galaxy was, the faster it was moving away from us. Not randomly, not by chance, in a precise, predictable relationship. He published this in 1929, and it became known as Hubble's law. If galaxies farther away are moving faster, that does not mean Earth is the center of the universe. It means the fabric of space itself is expanding. Imagine baking raisin bread. As the dough rises, every raisin moves away from every other raisin. A raisin twice as far away from you moves twice as fast, not because it is special, but because there is more dough stretching between you. That is what is happening to space right now. Every galaxy is a raisin, and the dough is still rising. A Belgian priest and physicist named Georges Lemaitre had actually reached this conclusion 2 years before Hubble published his paper. In 1927, Lemaitre used Einstein's own equations of general relativity to show that the universe must be expanding. Einstein himself resisted this idea. He had added a term called the cosmological constant to his equations specifically to keep the universe static, unchanging, fixed. When Hubble's observations confirmed Lemaitre's math, Einstein reportedly called the cosmological constant his greatest blunder. But the expansion was only the beginning of the mystery. In 1964, 2 radio astronomers named Arno Penzias and Robert Wilson at Bell Labs in New Jersey were trying to calibrate a large horn antenna. No matter where they pointed it, they picked up a faint, uniform hiss. It came from every direction. It did not change with the time of day or the season. They cleaned pigeon droppings off the antenna. They checked every electrical connection. The hiss remained. What they had accidentally discovered was the cosmic microwave background radiation, the leftover heat from the Big Bang itself. This faint glow, coming from every corner of the sky at a temperature of just 2.7 degrees above absolute zero, was the afterimage of the universe when it was only 380,000 years old. It was proof that the universe had a beginning, a hot, dense starting point, and it had been cooling and expanding ever since. Penzias and Wilson won the Nobel Prize in 1978. For decades, scientists assumed the expansion was slowing down. Gravity pulls matter together. So surely the mutual attraction of all the galaxies in the universe would be gradually breaking the expansion, like a ball thrown upward that slows as gravity pulls it back. Two independent teams set out to measure that slowdown in the late 1990s. One was led by Saul Perlmutter at Lawrence Berkeley National Laboratory. The other was led by Brian Schmidt at the Australian National Observatory, with a key member named Adam Rees at Johns Hopkins. They studied Type Ia supernovae, which are exploding stars that always reach the same peak brightness, making them perfect distance markers across billions of light years. What they found was the opposite of what anyone expected. The supernovae were dimmer than they should have been. That meant they were farther away than predicted. The expansion was not slowing down, it was speeding up. Something was pushing the universe apart faster and faster. Scientists gave this mysterious force a name: dark energy. It makes up roughly 68% of the total energy in the observable universe. We cannot see it, we cannot touch it, we cannot detect it in a laboratory. But it is accelerating the expansion of every galaxy away from every other galaxy right now. Perlmutter, Schmidt, and Rees shared the Nobel Prize in Physics in 2011. We have confirmed this expansion with increasingly precise instruments. The Hubble Space Telescope, launched in 1990, refined the expansion rate to a number called the Hubble constant, roughly 73 kilometers per second per megaparsec. That means for every 3.26 million light-years of distance between you and a galaxy, that galaxy is receding 73 kilometers per second faster. The Planck Space Observatory, launched by the European Space Agency in 2009, measured the cosmic microwave background with extraordinary precision and calculated a slightly different number, around 67 kilometers per second per megaparsec. Scientists are still working to reconcile that difference, and it is one of the biggest open problems in cosmology today. But nobody disputes the expansion itself. It is confirmed by redshift surveys of millions of galaxies, by the cosmic microwave background, by the distribution of galaxy clusters, and by the observed cooling of the universe over time. Here is what this means for you. Right now, there are galaxies so far away from us that the expansion of space is carrying them away faster than the speed of light. This does not violate relativity because it is space itself stretching, not objects moving through space. These galaxies are not breaking any law of physics. They are simply so far away that the cumulative expansion of all the space between us and them exceeds the speed of light. Their light will never reach us. They are already beyond our cosmic horizon. We will never see them, never communicate with them, never know what happened there. One day, in the very far future, the night sky will be almost completely dark. The galaxies will have receded so far that their light will no longer be visible. The cosmic microwave background will have stretched to undetectable wavelengths. The evidence for the Big Bang will be gone. Any civilization that arises in that era will look up and see a handful of nearby stars in their own galaxy and assume that is all there is. They will not know about the expansion. They will not know about other galaxies. They will have no evidence that the universe ever began. You live in a privileged window. You live in an era where the light of billions of galaxies still reaches your eyes, where the afterglow of creation still fills your sky, where the expansion has not yet erased the evidence of how everything started. The universe is stretching apart. Every second, the distance between you and the farthest things in existence grows wider. You cannot stop it. You cannot feel it. But you are the only generation of humans that can still see it happening. Look up tonight, because what you are looking at will not be there forever.